We're going to take a tour around the periodic table. You should know it by now, but anyway, let's try and go through it very carefully and slowly so that you know exactly where you are. So most of this should be revision, but let's remind ourselves. First thing is that when we look at a periodic table, we have got going across the periodic table periods. So that's period number 1, period number 2, 3, 4, etc. So those are the periods. Just to clarify, we've therefore got hydrogen and helium in period 1, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon in period 2, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon in period 3, period 4, potassium and calcium, and then things start getting a bit mushy and you don't have to worry too much about it, but you can certainly think that that's all period 4, period 5, period 6, period 7. Moving on to groups. Now the groups all go down. And in the transition metals you do have groups, but we tend to focus on this being group number 1, group 2, group 3, although your periodic table says 13, 4, 5, although it says 15, 6, 7, and 8. I prefer to use those numbers. You can use the teen ones, but you have to remember how you would use it to work out valency and valence electrons. So those are your groups. Some of the groups have got special names. So for example, group 1 over here is called the alkali metals. Group 2 is the alkaline earth metals. I do suggest that you decorate your periodic table very nicely. Better than me, I hope. The 8th group are called the noble gases. The 7th group are called the halogens. The 6th group are called the chalcogens. And the others don't really seem to have much of a name, so you don't really need to know them. Then what happens is this block in the middle over here are called the transition metals, or sometimes they're just called the transition elements. This block over here are called the inner transition elements or metals. Which brings me to the point that we can divide the periodic table into metals and non-metals along that line over there. These elements are actually semi-metallic, so they have some metallic and some non-metallic properties. And over here you've got hydrogen, which really is a non-metal. In some ways it's got one outer electron, so it belongs in group 1. But then in other ways it belongs over here because it is a non-metal. Helium has 2 electrons, so sometimes it should be over there. Some periodic tables put hydrogen and helium in the middle over there because in many ways they are quite confused. They behave strangely in many ways. So anyway, back to the metals and the non-metals. So your non-metals are all on this side of the periodic table. And your metals dominate. There are lots more metals than there are non-metals on the periodic table. So that's kind of a little bit of a guided tour around the periodic table. What's important about the periodic table is it's a beautiful pattern. It tells a lovely story of rhythm and rhyme. A chap by the name of Dmitry Mendeleev came up with the periodic table concept, and he realized that all the elements in group 1, because they've got the same electron outer structure, behaved similarly. Group 2 the same thing, group 3, group 4. Even if you start to go down some of the other groups, for example, copper, silver, and gold, all can be used for jewelry. They're all fairly inert. Same with platinum, palladium, and nickel. They can also be used for a number of household uses and jewelry uses because they do not react easily with skin. Manganese, iron, and cobalt are very strong. So when elements are near to each other, they tend to have similar behavioral patterns. The noble gases all behave in the same way in that they do not wish to bond because they have a complete outer energy level. The halogens want to gain 1 electron, so they're highly reactive because they're very keen to get that extra electron. Group 1 elements are all highly reactive because they're very keen to lose an electron. and we'll explore group 1 in a little bit more detail later on. So, just looking at the notes that you've got, you need to divide your periodic table along the metal-non-metal line. You know what the periods are, you know what the groups are. The concept of periodicity is what you need to focus on. It means a recurring pattern at regular intervals. And when we were doing the alpha diagrams, you will remember hydrogen, lithium, sodium, and potassium all had 1 electron in their outer energy level. The same is true of, let's say, fluorine, chlorine, bromine, and iodine, all having 7 electrons in their outer energy level. They are different, however, in how many energy levels they have. Periodic table means that atoms are arranged in a table that occurs regularly. It refers to the outer energy electron structure of a particular group. Last year we just learned group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. We didn't know how that arose. It arises from having 1 valence electron, 2 valence electrons, 3 valence electrons, and you need to know what these valence electrons are, by the way. Valence electrons are the all outer electrons. Therefore, it goes 4, 5, 6, 7, and 8. It doesn't go, the other concept that we're going to come to when we do bonding is the concept of valency, and that's a different thing. Valency is how many electrons participate in bonding, and we're not doing that yet. We are just looking at how many electrons are in the outer energy levels. Remember, your outer energy levels have got 1, 2, 3, 4, 5, 6, 7, and 8, or 2 in the case of helium. And that gives them similar properties. Metallic properties increase from right to left and down. So your most reactive metal in the metals is francium. That's the most reactive metals are on the left, because they want to have, it's easy for them to lose 1 electron. And then the most reactive nonmetals are on the right, because it's easy for them to gain 1 electron. So your most reactive nonmetal is fluorine, because obviously the noble gases do not react at all.